first experience of the BNF onboarding task force with trying to build a real world KNF for the community. So building an evolved packet core KNF package from scratch. Magma is a mobile packet core which is addressing the 4G and also Wi-Fi access, is also heading to 5G. And it has some components that are already containerized, like their orchestrator and their federation gateway. And it also has another component. Let me follow the guide. So as you can see here, there is the orchestrator, the federation gateway. These are containerized, and then you have the access gateway, which is a distributed packet core. It includes the S gateway, P gateway, and MME. So this is a very lightweight packet core that is orchestrated by this element here, which can reside in the cloud. And both of them can work in a standalone. And then if you want to integrate to existing packet core, then you have this federation gateway component that will allow you to integrate both. Well, the resulting packages are already here, so you can download them if you want. But the idea is to build them from scratch. You will see that there's less to do in a KNF descriptor nowadays, because it's most of the complexities of the pods and the interconnections between them and the networking and the images and everything is kept at the Helm chart in this case, or the UU bundle in the case we're using that. What we're doing here is build a KNF descriptor. It's just a folder with a YAML that uses the same, of course, is a single information model of OSM that covers all use cases, so BNFs, KNFs, even physical network function as well. The main element in a KNF descriptor today is this KDU element. Remember, you had the BDU, now you have the KDU. You have seen this already in Gerardo's session. And it specifies the name of the repo and the name of the package inside that repo. That's the main information that you need to provide to the KNF. Then it needs to be packaged, of course, and then to launch it, you need access to the repo. I mean, OSM to access the repo, as you did with LDAP. Well, LDAP, I guess it comes with a default, takes the package from a default Helm chart repo. And in this case, you need to add a specific repo that Felipe here created, because he was the one building the Helm charts for the OSM community. So, any complaints to Felipe, please?
They are more than welcome. Yes, just a comment. The name that you put in your repo when you register it is the same that you use in the BNFD definition. This is very important to highlight, because if not, then the package will not found by the system. Okay, so these two are the name of the repo that you set when you add the repo is the same that you use in the BNFD.
Yeah, so if you put OSM here, you need to put here Helm chart OSM and the name of the package. The name of the package, it should match the name inside the Helm chart, the remote name. Then if you want to launch the KNF, of course, you need a network service descriptor and package. In this case, a network service, it has the same information, it uses the same model, and the main information you need to feed the descriptor with is the BNF, the name of the BNF, no? And the name of the BNF, or the ID of the BNF, and the BNF member BNF index. And so this is the constituent BNF. It's the same as in a regular BNF. You will notice that there is information that ties the KNF to a VIM, a network at the VIM. So this is being I think this is work in progress to make sure that you can select the networking that you need from the VIM where the case cluster is located. And then you package your network service, and now you're ready to upload both packages to OSM, and finally instantiate the network service. This particular, well, if you want to see the package, you can visit the cluster if you have access to the cluster, or you can see some information from the cluster about what was instantiated from OSM with this command, BNF show, the BNF ID, KDU, and the name of the KDU. In this particular case, you will see many components from Magma being exposed there. The most important ones are the ones that are exposing load balancer addressing, because when you configure a case cluster, you need to add some mechanism for exposing these services through a load balancer. So in this case, for example, the Nginx proxy, which has in this 250.4 IP address, is the one that we are visiting then for making sure that the BNF or a KNF was instantiated properly. And of course, these need to be configured because, as I have said many times this week, we don't do nothing with just instantiating, right? Otherwise, we would use, in this case, Helm. In the case of OpenStack, we will use Git, and that's it. We need to be able to configure that. So that's also work in progress. Right now, we leverage some Helm provided tools like Helm Upgrade. In the UU case, there is a Kubernetes framework, and we are getting there. I mean, there will be a way to describe some port or some API that the KNF exposes here, and a way to configure it through charms, for example, and to be able to provide any script that you want. And for now, day 1 and day 2 primitives, as we know them in BNFs, are not fully supported. You're just leveraging Helm tools for that. So basic examples like Helm Upgrade can let us redeploy the CNF, which is a different approach of operating these network functions. So that is it. I will now proceed and with this, building this so that we see that working. I will create this folder. I'm in the wrong VM, sorry. This is the right one. So I'm going to create that folder for the KNF. And then I'm going to create, I'm just using VI, the YAML file, and populate it with the contents that are here, so that you can see main information is here, Magma orchestrator. So I need to have a repo later on that that says where to find this chart. Okay, and then I convert it into a package by just compressing it, and that's it. That's the building of the KNF. We didn't go through the requirements of how many CPUs and memory and SRAOV and all the things, and cloud init, all the things that VMs use, because many of those things just don't apply here. However, there are certain things that will be added over time, because of course some of these pods may be data plane pods and may need other networking drivers in Kubernetes, or even an SRAOV connection. Now let's add the repo. first of all, let's visit it so that you know where this comes from. This is Felipe's repo that is hosting the Magma Helm charts, and it has a README as well to this GitHub page as well. Here you will find the orchestrator. I don't know if you want to describe things a little bit here, Felipe.
Yes, well, basically, this folder contains the Helm chart, and it's composed by a set of charts that if you go to the inside the charts folder, please, then you can see that we have some charts for logging, other charts for database like MariaDB, Postgres, secrets to automatically configure the secrets part of the orchestrator, and the NMS that at the end will be the front end of the Magma orchestrator. Okay, that's okay. You have there a lot of YAMLs. Yeah, so it's a complex service.
Yeah, so that's what I was talking about when saying that most of the complexities are inside the Helm chart. We just OSM consume that and add all the would call it the NFV features that would allow this us to handle this application as a network function. Okay, so that's our role here in OSM. So I'm going to continue. I have the package already. Now on the repo, I will add the repo. So repo add, type Helm chart, because there will be more types of repos in the future. There you go. We have the Magma repo tied to this URI. Okay, and then I'm going to create a network service. Because if we want to launch something in OSM, we need a network service, right? To be able to potentially mix this VNF with other VNFs to provide a more comprehensive service. So I'm going to paste the contents. As I was saying before, the main information is here in the constituent VNF section. Okay, and now we should package it. There are, I was telling the first day or second day that there is a command, it's called OSM package build, that is coming to replace this. And with both packages ready, I'm going to upload them to OSM. So now, if I visit my instance, we will see there the KNF, and we can potentially modify things here. And then the network service packages as well. Okay. And now back to the guide. The next step is to launch it. So I should have a Kubernetes cluster first, of course. For that, I have linked here the user guide where you can see how to create a cluster. You already know that from the previous session. I have my cluster ready. I guess I'm going to double check. Okay, yes, it's enabled. And the Veeam account is just white cloud. Okay, so now I can monitor two ways directly in the cluster. So for example, get pods. We have here all the Magma components, the NMS, orchestrator itself, metrics components, the database that will take some time to instantiate. And we also can check our VNF list to see the VNF and then show it, and then put the KDU knob, and if we know the name of the of the KDU. You can see it, sorry, here. It's called orchestrator. I mean, orc8, or that comes from Facebook. Don't blame us. So, okay, we are ready. This triggers an API call to the Kubernetes cluster in the form of an operation in OSM. And we can see what was instantiated in the cluster. Very comprehensive, because it's like running to show all the resources that are dedicated to this particular KNF. So a cluster role, config maps, deployments, jobs, persistent volumes, the pods, and the status of the pods. And there's this Magma LT in this particular version of our Helm chart. Will take a couple of minutes. And then we have the secrets, and then the services. And here in the onboarding guide, you will see that that services part is important, because it will show us the IP addresses to visit, for example, the web, the front end. So I'm going to try to visit it. Here we go. We may
remember the day one operation that you
yeah, yes, about to, yeah, thank you. So this KNF needs some configuration in order to run smoothly. We have minimized that to one single command that is pending to be automized, and we will do that as soon as we can count on day one primitives, okay? But for now, we'll run it manually. It's a command that will let us actually authenticate well, and let the NMS authenticate with the main controller. So I will run that command, and I'm not sure if it's worth it to put it in the guide, but anyway, I keep it here. It's a command that needs to run inside the Kubernetes, the controller. It's not exactly like this. I'm executing a command inside the controller pod. Okay, so controller pod. I'm running this command to set a certificate inside the controller pod. So this is a typical command or operation that I will need to automate, right? So we will be there soon in OSM, be able to run commands inside the, sorry, container not found. I think oh, okay.
Okay, yeah. When appear this log about health and service and so on, yeah, you can.
I can. Perfect. So I'm going to
dash ti bash.
I have my shortcuts. Okay. So now, if we visit Magma NMS, the credentials are in the guide. Don't worry. There we go. So we have our orchestrator, and it's not configured. So bear with us. We will add configuration. For example, we need to add a network and things like that in the orchestrator to see it running. In the meantime, we have an example here on how to validate that this does something. What we can do is create a access gateway. So the other component down here is the access gateway. This is the packet core actually. The orchestrator is just there to configure it would be, from the OSM perspective, in NFV, it will be, orchestrator will be like the EM or EMS of the BNF, which is the access gateway. I see it that way. So, or the orchestrator could be considered as a separate VNF because it can handle many distributed VNFs at once. So it doesn't necessarily need to be inside the network service of an access gateway, because you will have usually one orchestrator or two orchestrators, not more than that. So let's try this and download the packages of this VNF. This VNF, as I said, is the access gateway. I already did. Okay. And I guess this is created as well. Yes. So we are going to prepare a params YAML file. Let me see if that's created. No. This params YAML file is a way, as we saw yesterday, it's a way to feed the VNF with information of the particular environment. I want this access gateway to register with the orchestrator. However, we need to provide the IP address of the orchestrator. And what's the IP address of the orchestrator? It is the one of the proxy here, 118. So 118 will be provided as an instantiation parameter. And
yes, yes. This additional param for VNS, since it is a VNF, then it has its charm and it's automated by the charm and so.
Yes. So this, let's see that VNF, because it's an interesting one that you can use as well. This is a VNF package. A traditional virtual machine based network function. It has the monitoring params, an image that I will share soon, but it's heavy now, so I need to move it to the FTP folder. It has some EPA, but it has the charms. So it would add itself but this is not the. This is not the most.
When you upload the packages,
yeah.
give you a conflict. So maybe you have to delete this.
No, it's okay. It's okay. It's okay. It has the latest information. Yeah, thank you. So it has information to the primitive to add a network. This is the initial config primitive. So these are the ones running in day one. First of all, it will reset the ID. I mean, this access gateway will refresh its identity. Then it will add a network in the orchestrator in case it doesn't exist. Then it will add itself as a gateway in the orchestrator. So we are running the charms that maybe should be run in the orchestrator, but in the access gateway whenever it gets instantiated. So it's like a zero touch for the gateway, doing it from the VNF that is being registered in the orchestrator. And finally, add the host. So, well, this is just DNS or network name resolution. And finally, restart the service. Okay. So, and there is a charm for all of this, just Linux commands that run. I can show it. That run different primitives. No, the charm is in the charms folder, and then the reactive file, if you remember, is the one containing the logic that we want to use. So add network, it runs a script that is contained in this particular image of Magma access gateway, which adds a network in the orchestrator. At gateway, it adds itself as gateway. So these are just Linux scripts that are already present in the machine. Restart is just restarting the services, things like that. Okay, so let's instantiate now. So this information is in the slides. I already prepared this file, and now we would need to launch it. Vim account would be white glove, and a pass config file. Okay, here we go. So now we have the Magma Access Gateway being launched. It's active already, but we have to wait for the charms. So you switch to the model and then status of the charms. Okay, it's installing the agent, initializing. There are some tricks that we can use for accelerating the charm execution. They are documented in the previous Hackfest session. I mean, the one that was in Italy. That material contains some commands that you can run to accelerate this installation. But since we're moving to a new framework, which is faster, then that shouldn't be a problem anymore. In the meantime, we can see what a charm is doing. If it's in a framework or the other, it doesn't matter. It will create a charm, code that will be contained somewhere, in this case in the LXC container, and it will do stuff in that container to install there's a controller that installs the code that your VNF needs in that container, and that container will connect to your VNF and execute the code, the charms, the primitives. So it's already finishing. Now it will start running the primitives that are relevant for our use case. For now, it's trying to authenticate. It's still missing the host name. Still, okay, very well. We have the host name 28, which is the management IP address, and now it will try to authenticate. It will reset the ID first. It was the first primitive we defined in the descriptor. And then as soon as it's done with that, it will clear that flag and proceed to the next primitive, which is the add network, which runs against the orchestrator. And that should have configured a network in the orchestrator. So now we got a network, OSM net. It was configured by the access gateway itself because it couldn't find a network, so configured. So this is a primitive from a VNF running to the containerized network function. And now it will add some network name resolution. And it should have registered already here. Let's see. It should have registered as an access gateway. There it is. And finally, it will restart Magma so that the access gateway authenticates with this orchestrator in the proper way to enable all the services, and finally be ready for traffic, for integrating with Node Bs and everything. So in short, this will become green, and the hardware UID will appear here. From the OSM perspective, I think this is ready. It ran already all the primitives. So we are seeing, we can potentially merge these two in a single network service, and this would be an auto-contained packet core, which can be put anywhere. And we can put out the scaling functions in the access gateway, for example, whenever we have more traffic than the access gateway can handle, and things like that.
Yeah, Pietro. Another option is to create a slice with the shared with a shared orchestrator, and each gateway is a separate network slice of net, so you can create instantiate multiple times the network slice, but only one instantiation of gateway.
Yeah, that's great. I'm glad you are here, the slice guy. Yeah, that would make complete sense to have the orchestrator. Let me show the diagram. To have the orchestrator as a shared instance, right? And
yeah, exactly.
All the slices that the access gateways can have, and potentially these slices could go to different operators in case it's a business model like that. That takes us to the end of the session. I hope you enjoyed this. Remember that this is the work we are doing, the task force in which Felipe is a very active participant. This is all work in progress. We are constantly looking for use cases to apply all the features that OSM has, so to show its value over BNF's life cycle. So any feedback is welcomed, any suggestion, and also we would like many participants to join to our task force. You just need to sign up to the email, sign up to the Slack, and be active. I mean, suggest things, maybe provide your own examples. For example, last period, Tolga here, he provided a walkthrough of a commercial BNF, which is awesome. We have the pending task to upload it to the documentation as well. And anything that is related to onboarding is any contribution is more than welcomed and needed. Thank you, guys. And this takes us to the end of the Hackfest. So yes, you can assist to the tech sessions are still going up till tomorrow morning. So enjoy the rest of the week.